I think BrightSparks has been fantastic. So lots and lots of people who've done really incredible things, talking about the things they're passionate about. So kind of wandering around the event, seeing people who've done really cool things, and that is being celebrated. So I think the really exciting thing about the time that we're in at the moment is we've got a situation where open source computing is really accessible. So we've got things like the BBC Microbit, we've got Raspberry Pis, Arduinos. So I'm in a situation where kids can be learning that stuff from a really young age and engaging with programming as a way of kind of accessing electronics. Whereas in the past, people often found their way into programming from making things. Actually, we've got a situation where kids are finding their way into making things from programming. So it's sort of, the level of skills that are there that are enabling kids to kind of grow and do things in the future is pretty unprecedented. And I think we're going to see a wealth of science and engineering skills in the future coming out of that. The thing that inspired me into engineering was, so I grew up on a small holding, so where kind of making things and kind of fixing things was a part of kind of growing up. So for me, kind of understanding how things work, taking things apart and kind of interrogating how they worked was a big part of things for me, but also design and technology in school. So being able to kind of do things that were kind of art and design focused, that kind of naturally transitioned into engineering principles was a big part of where my engineering career started. I think it's really important to have, the growing term for this is STEAM, so this idea of bringing the arts into science, technology, engineering and maths. So when I finished my engineering degree, I went and did a master's in fine art afterwards, because I wanted to be able to kind of have some more of those creative skills that sometimes get lost a little bit in education, to kind of supplement some of the engineering skills. The interesting thing about the YouTube stuff and kind of engaging with kids and their ideas is that for us it starts with a kid's drawing. So it starts with kids kind of drawing their idea for something that they think could be brought to life. So it starts with a kind of art and design process, and that feeds into the engineering through the kind of journey that we take that kid's idea on. So it is really important to have a kind of artistic starting point. For me and kind of the stuff that we do, electronics is another tool like a hammer or a screwdriver and things, but the exciting thing about now is that those solutions are like stupidly accessible. You can spend £3 on a full working computer that in a matter of hours you can have up and running and doing things that in the past, even 5 years ago, were completed by a desktop computer. And the fact that kids can be doing that in school for virtually no money, that's pretty unprecedented, and it's something that's going to have a massive impact for the future of engineering and technology. So I suppose for us, for kind of our ambitions moving forwards, is to carry on building crazy inventions on YouTube for kids, but we're kind of, for us, a big part of what comes out of that is the excitement of being able to bring those ideas to life. So doing more of that on a bigger and better scale and reaching more people is kind of the aim moving forwards.